Thank you everyone for attending this presentation. There are a few of us up on stage, and there's also a few other PyGeoAPI committers here. So happy to see the presence and happy to see everybody's interest. Today we're going to give you an update on the PyGeoAPI project. We will walk through an overview of the project for those of you who may not be familiar with it. We'll give a description of its core capabilities, what we've been up to lately, some featured projects that are utilizing PyGeoAPI, as well as what our future plans are and how you can get support. PyGeoAPI is a GeoPython project, and it was created in 2018. And last year at FOSS4G in Florence, we became an OSGeo project. It's a geospatial data web API framework written in Python, so a server implementation whose goal is to do all the OGC API standards. The OGC API effort is an activity to modernize the way we do APIs for geospatial services in OGC, and the goal of PyGeoAPI is to implement all of those OGC API standards. So it takes on the patterns of REST, as a result, REST, JSON, OpenAPI, Swagger. It's OGC compliant to OGC API features, as well as OGC API environmental data retrieval. Like I mentioned, it's an OSGeo project. We really have an international team from numerous countries and numerous time zones, and we stand on the shoulders of a number of different upstream projects who have helped get the project to where it is. Whoever was here for the PyCSW presentation saw that we had a 4-minute install. So for PyGeoAPI, we have a 5-minute install. Might take you 5.5, hopefully not 6, right? So the basic idea to get it up and running is on our website, which is pygeoapi.org. And with a few simple steps and configurations, you should be able to stand up a relatively lightweight server. The way PyGeoAPI is implemented is as a core abstract API, and it's agnostic to web framework. So for those of you who are into Python, it can work with a number of different Python web frameworks, and it can work with a number of different Python packages and plugins underneath, which I'll show in the next slide in the diagram, at least. We put forth a very simple YAML configuration, and we automate the OpenAPI document generation, which are required for all of the OGC API specifications. We're built on a robust plugin framework. So everything we try to do in PyGeoAPI is built on a plugin, and it's extensible. So we try to follow the OGC API pattern of core and extensions for specifications in doing that in the actual software as well. Relatively easy to deploy, whether you want something very simple via pip or Docker or Conda, or if you want something like Debian or Ubuntu GIS for that matter, a number of different options in terms of installing the tool, which is important because a number of us have different requirements and deployment scenarios in our organizations. And we try to run the whole thing with a minimal set of core dependencies. Obviously, you can add your own as things evolve in your application. There's a very high-level diagram. It may not look that great on the screen, but the idea here is we have a core API right in the middle, which accepts a configuration, a YAML configuration that I mentioned, and it's able to generate the required OpenAPI document. And then below the core API, we have this plugin framework. So we have the idea of having plugins to add new features and add new capabilities. So whether we need to add a new plugin to do processes, or whether we need to add a plugin to read a database for a feature provider or a coverage provider or a metadata provider, we have a number of different types of plugins to make that happen. Or if you would need to write a new output format, for example. So that's the basic idea. And then on top of the core API, we are web frameworks agnostic. So whether you are using Django or Starlette or Flask is our default, for example, you're able to put that on top of PyGeoAPI accordingly. Gonna move it over to Angelos.
Thank you, Tom. So this is a description of our provider plugin framework. For example, as Tom mentioned, for features, we have providers for Elasticsearch, for Postgres and PostGIS, Of course, we can use CSV files, GeoJSON, an OGR backend, and several other feature backends. For coverages, we implement providers for Xarray and raster IO. And same for tiles, we have mini IO and directory trees. For records, we support Elasticsearch and TinyDB. And of course, you can implement your own backend. Then also for the processing framework, we expose the Python workflow as a process. There's a process manager support for job control, which is based on TinyDB. And of course, you're free to implement your own plugin and propose it and make a pull request to us so that it can run in the core system, or you can maintain it in your own repository. So here we have, on top of everything, we have schema.org support lately, so we lower the barrier to data search, so everything that is exposed through the API is easy to be crawled from search engines, and the HTML annotation is there, so search engines can actually crawl the data and provide them in their form. We also support linked data and JSON LD as an additional representation for out of the box functionality for most resources and endpoints. In order to deploy PyCSW, of course, as in every Python package, the package is available through the Python package index. We are doing also Debian packages. We provide a Docker image on Docker Hub. It's available on Conda and also on FreeBSD. And I'll pass it on to Francesco.
Thank you. Thank you, Angelos. Core capabilities. We support a number of core capabilities from the modern OGC specification. Here we have the land page where there are some of them. Let's go through what is supported in terms of standards. But first of all, we have to, it's important to say that the core foundation is OpenAPI. So everything in pygeoapi is based on the OpenAPI specification. So, well, don't expect, if you are wondering about WMS, WFS, don't expect to be supported in pygeoapi. But we support at some point protocol translation of the legacy standard into the modern one. We support OGC API features, and we are a reference implementation of the OGC API features. Coverage, we already seen that is supported through Xarray and Rasterio. So you can put it up your raster data and streamline OGC API coverages. We support metadata with the new OGC API records through the Elasticsearch backend and TinyDB. Here you can see you can even consume from QuantumGIS an API records from pygeoapi from the desktop. Recently, OGC API maps, which is in draft, has been added, and we support translation of a map server map into the new OGC API maps. Tiles, OGC API tiles, specifically at the moment for the vector data, is supported. And so you can basically pre-generate your vector tile. We delivered a workshop where we showed how you can generate your vector tile and streamline in web mapping tool these styles. Processes is another standard that we support and can be executed in a sync way or in a asynchronous way. There is a talk later that will improve even the management of processes. So I guess you can even improve your knowledge how to manage processes. And also we support EDR. So you can put in the pygeoapi configuration the aggregation of your any eventually aggregation of raster data and vector data, and streamline again hierarchical data from the backend. Over to just.
Yeah. Okay. So I will lead you through the latest developments. Latest in the sense since we last presented in Florence. We had 3 major releases, still not at 1.0, but well, you can look at the release notes, but I'll show the main features that have been added. And a lot of it has been added by participating in various code sprints. And also there's early adoption of standards, even when they are not entirely finished. So here you see the various code sprints in which we participated, like the OGC, OS, Geo, Apache Software Foundation joint sprint. I will show a bit what has been added in each of these sprints. So the OGC API transactions was added, which is the standard OGC API features part 4. It's available for some backends, not all backends yet, but you can imagine like it's available for Post.js, for instance. OGC API maps, what Francesco already mentioned. So with at least 2 backends, and WMS facade may be interesting because it allows you to have pygeoapi basically proxying to your existing WMS. This may be a migration path. CRS support, which comes down to the full implementation of OGC API features part 2. And it's available for all feature providers. And what is available? It means that you, first of all, you don't have to reproject your data first. You can leave your data in your own projection because you can specify in the configuration what the projection is, and it allows you, there's a new CRS parameter, as in the standard, which allows you to fetch the features in a projection that's, well, whichever projection you want. And we implement it for all feature providers, even for, let's say, CSV. And some backends can do the reprojection internally, or it's delegated to the core. And here we saw also community cooperation, which is sort of a luxury, because once we opened the issue, we had like 3 PRs coming in. So there's more like managing various contributors. One major contributor is Mathieu Tagon from the Norwegian Mapping Agency. And I should say, this was based on a tender given out by GeoNovum to implement OGC API features part 2 in various, not just pygeoapi, but also in GeoServer and various servers. Okay. Also there in the tender was adherence to Dutch API rules. That may be, some of it may be interesting. It's an optional feature. You can switch it on or off. And there have been some new interesting plugins like the Esri REST API. It allows you to unlock features from a remote Esri feature server, although you could do that already with the OGR provider. Azure for the STAC, and AirDAP allows you to access a large number of scientific datasets. And there's a MongoDB process manager, and well, the list goes on. More new features: Django support, JSON minification option, JSON LD templating. And Inspire. Inspire. That was also part of the GeoNovum tender, and well, collection links, but also most importantly, what is called enclosures, which allows you to download an entire data set. I get metadata from that. I think it's, I hand it over to Tom.
Yeah. Thanks, Jus. So quickly, we'll go also over some selected recent projects. So Spain, the National Cartographic System of Spain and National Geographic Institute has recently deployed the pygeoapi in production for both maps and features, and they're working on coverages and processes as well. They're actually the first deployment that I've seen of OGC API maps from pygeoapi at least, so big kudos to them. And there's some examples of some of their applications, so great to see this. From a UN or World Meteorological Organization perspective, there's been a couple of projects that have been using pygeoapi. One is called WIS2Box. We presented on this last year. This is an event-driven sort of data exchange tool, for a publication tool for weather, climate, and water data. It has an API component, and that is powered by pygeoapi. We also have another project called OpenCDMS, or Climate Data Management System, for managing climate data, and it serves the same capability by providing the API component there. Gonna move it over to Francesco.
Roadmap. We are going to support PubSub with the new trend of event-driven pattern, and we participated already in April 2023 in a sprint, and we will improve this pattern. We are approaching version 1.0 where it will be OGC API styles. We are planning to make some API refactoring and more long-term stability in terms of dependencies. We are going even to add new provider like Oracle and TileDB, and more specifically HTML templating. We offer, well, a number of service providers can offer you eventually for customization and development their services. Here the list. And I'm going to the point. We are giving away a couple of t-shirts here for the most interesting question. For those who are not here and want to take the t-shirt, you can go online on OSGeo Redbubble shop and take your pygeoapi t-shirt, hoodie, sticker, whatever it works for you. Here, links of the various social platform, documentation, our demo, and other. We can reach the developer in the new former GitHub in the new element. Thank you.